Hello students, I am Nikhil Mishra, your physics mentor at NEETKAKAG, and I am going to discuss the physics paper in front of you. And the physics paper, we have actually written the questions over here. So this is not code specific basically. Okay, but the questions will be in front of you, and then I'll be telling you the solutions of the questions so that it becomes clear to you. And also you can then generate the answer key yourself, and answer key will also be told, so you can take down the note of the answer key. So the first question is, the phase difference between displacement and acceleration of a particle in simple harmonic motion. Okay, so the phase difference in between displacement and acceleration of a particle in simple harmonic motion is pi. Because suppose a displacement x is equal to a sine omega t, then acceleration becomes minus a omega square sine omega t, so that minus factor comes in front, so the phase difference is pi. So obviously your answer will be D over here. Okay, now the next question is, a long solenoid of 50 centimeters length having 100 turns carries a current of 2.5 amperes. The magnetic field at the center of the solenoid. So you remember that this is a long solenoid, magnetic field at the center is mu naught Ni, and because the magnetic field at the center is mu naught Ni, you can simply utilize the formula to obtain your answer, which comes as the option D, that is 6.28 into 10 to the power minus 4 Tesla. You can put the value of mu naught as 4 pi into 10 to the power minus 7. N is what? So it is 50 in 50 centimeters length, there are 100 turns, so it is 2 turns per centimeter, okay, basically. And then current is also given to you. So this is a very simple question. One more thing that I would like to tell you, that this question emphasized, or basically this entire paper emphasized more on memory rather than basically concepts. Okay, so more than concepts, this paper was utilizing memory, and we cannot say that this was the shortcoming of paper, because in a time frame of 1 hour, when you'll have to do 45 questions, so you cannot expect the questions to be very conceptual. You cannot expect the questions to be out of the box. What you'll have to do, the exam basically targets that you solve 45 questions in 1 hour. So basically it checks your formula applying ability. So most of the questions were put the value and get the result. Okay, in some questions there were some calculations, but yeah, that is expected as far as physics is concerned. Okay, so now let us go to the next question. So the next question is, two bodies of mass 4 kg and 6 kgs are tied to the ends of a massless string. The string passes over a pulley which is frictionless as shown in the figure. The acceleration of the system in terms of acceleration due to gravity. So you already know the formula, that it is net pulling force upon total mass. So net pulling force will be obviously 6g minus 4g, because 6g is weight on one side, 4g is weight on the other side. So it is 6g minus 4g upon total mass of the system. So it is 6 plus 4. So it is 2g by 10, which comes as g by 5. Okay, so g by 5 is the correct answer. So the correct answer is B. So these are the very conventional, and these are very easy questions. So this is a very easy question of Newton's laws of motion. As soon as we study the Pulley system, this is the first numerical that we solve. Okay, now the next question is, the ratio of contribution made by the electric field and magnetic field components to the intensity of electromagnetic wave. So this is basically, everybody of you know that the answer is 1:1, because electric and magnetic fields run perpendicular to each other, and the intensity contribution of both of them is equal. Okay, so the answer will be 1:1. So the answer is A, obviously. Next question is, in a certain region of space with volume 0.2 meter cube, the electric potential is found to be 5 volts throughout. The magnitude of electric field in the region is. Now you know that electric field E is equal to minus dV by dr, and because electric field E is equal to minus dV by dr, and because potential is constant, so if you differentiate potential, your answer is obviously going to come as 0. The electric field is going to come as 0, so 0 is the answer. So the correct answer over here is D. Okay, okay, now let us proceed into the next question. We are doing it as fast as possible, so the answer key becomes available to you as fast as possible, and I'm also not only delivering the answer key, I'm delivering the solutions also to you. So the next question is, the average thermal energy of a monoatomic gas, okay, where Kb is Boltzmann constant and T is absolute temperature. So you'll have to state in terms of Boltzmann constant and absolute temperature. So for a monoatomic gas, you know there are 3 degrees of freedom, so it becomes 3 by 2 Kb into T, and this is the, obviously I think the first formula that you read in KTG is this only. So this is as simple as this. Okay, if a candidate was sincere enough, if he remembered all the formulae thoroughly, the physics paper was not more than 25 to 35 minutes. Okay, this paper was so simple. Okay, now the next question is, find the torque about origin when a force of 3J Newton acts on a particle whose position vector is 2k cap meters. So you know that torque is equal to R cross F. So what you will do 2k cross 3J. So it is 6, and in bracket you are going to write k cross J, and k cross J is going to become minus I. So it is minus 6I cap Newton meter. So obviously our answer comes as B. So the answer is B. Okay. Now, let us come to the next question. This next question basically we can derive, okay, but this is memory based also. If your memory is sharp, you remember this question. So the next question is, the mean free path for a gas with molecular diameter d and number density n can be expressed as, and most of you must be remembering the answer, that the answer is A, that is 1 by root 2 n pi d square. Even if somebody fails to remember the answer at that particular moment, he can utilize the concepts of dimensions, and then he can easily come to the conclusion that the answer is A. Okay. Now let us move to the question, next question, that is question number 99 appearing on your screen. So the energy equivalent of 0.5 gram of a substance is, now you know that E is equal to mc square. When you write the equivalent energy for mass, utilize E is equal to mc square. So simply what you are going to put, 0.5 into 10 to the power minus 3, because it is gram, and into c square. So it is 9 into 10 to the power 16, and when you multiply you get the answer as A, that is 4.5 into 10 to the power 13 joules. Okay. Now let us come to the next question. So the next question is, a screw gauge has least count of 0.01 millimeter and there are 50 divisions in its circular scale, and our aim is to calculate the pitch of this screw gauge. Okay. So basically what is the least count? So you know the formula for least count, that least count is equal to what? It is pitch upon number of divisions on the secondary scale. So basically pitch will be what? Pitch will be equal to least count into number of divisions on the secondary scale. So it is pitch is 0.01 into 50 millimeters. So it is equal to 0.5 millimeters. So it is as simple as this. Okay. Now the next question is, and we are doing the questions fast enough so that you can just, because there was nothing to discuss over here, all the problems were formula based only. So let us come to the next question. So the next question is again a very simple question. It states that two cylinder A and B of equal capacity are connected to each other via stop cork. A contains an ideal gas at a temperature and pressure, okay, at a standard temperature and pressure, and B is completely evacuated. Now this is the point, B is completely evacuated. The entire system is thermally insulated initially. The stop cork is suddenly opened, the process is, now when you are suddenly opening the stop cork, heat exchange is not occurring from the surroundings. Okay, so delta Q is equal to 0. More importantly, because one chamber was evacuated, the process is fast. And if the process is fast enough, then we will, instead of opting isothermal, we are going to opt it as adiabatic. Also because expansion is happening over here, so we are going to go for adiabatic cooling. So your answer is adiabatic process. Okay, so the answer is A. Now, the next question is, a cylinder contains hydrogen gas at a pressure of 249 kilopascals and temperature of 27 degrees Celsius. What is its density? So you already know the formula for density. It is pressure into molecular mass upon your universal gas constant into temperature. Just utilize this formula and you're going to get your answer as A. Okay, just put the value and get the result. It is as simple as this. Okay. So now let us move into the next question. So the next question is, when an uranium isotope, that is uranium 92-235 is bombarded with a neutron, it generates krypton 3689, 3 neutrons and what? So what you will have to simply do, you will have to balance the equation. Just write the equation on one side. That is, on one side what you are going to write? You are going to write uranium 235-92 plus 3 electrons, and on the other side you are going to write it as krypton 89-36 plus 3 neutrons plus the substance that is balancing the atomic weight and atomic number. Okay, so the answer comes out as the barium 56-144. You can simply balance the equation and get the answer. Okay. Now, the question number 104 is a charged particle having drift velocity of 7.5 into 10 to the power minus 4 meter per second in an electric field of 3 into 10 to the power minus 10 volt per meter has a mobility in meter square volt inverse second inverse of. Okay, you already know the formula for mobility. You already know that mobility is drift velocity per unit electric field. Now this is one of the easiest question of current electricity that is going to appear in the examination. Mobility is drift velocity per unit electric field. You see the standard of the paper that no question was based on circuit, and maybe this is the first year when very simple question of electrical instrument is there, that is a simple meter bridge, and it is not acquiring, or it is not requiring a potentiometer in its entirety. Okay, so this is one of the simplest questions. So now in this particular, as far as this particular question is concerned, we have mobility is equal to drift velocity per unit electric field. Just put the value and you get your answer as A, that is 2.5 into 10 to the power 6. You have drift velocity given 7.5 into 10 to the power minus 4 divided by 3 into 10 to the power minus 10, and this is going to be your answer. Okay, now the next question is, taking into account the significant figures, what is the value of 9.99 meter minus 0.0099 meter? Now, from the rule of significant figure, you already know that the number of significant that is going to appear, the number of significant figures that is going to appear in the final answer must be equal to the number of significant figures in the quantity having least number of significant figures. So over here, in between 9.99 and if we compare 0.0099 meter, okay, so 9 meter, what we have over here, so our answer is going to come as 9.98 meter, because we are going to have 3 significant figures over here. Okay, now let us come to question number 106. So in question number 106, that it is given that an iron of susceptibility 599 is subjected to a magnetizing field or to 1200 ampere per meter. The permeability of material of the iron rod is. So the permeability of the material is what? So mu naught is equal to 4 pi into 10 to the power minus 7 Tesla meter per ampere. It's given to you. So what you will have to do, you will have to just, you already know that mu r is equal to 1 plus susceptibility. Okay, so you already know that mu r is equal to 600, because mu r is equal to 1 plus susceptibility. So mu r is equal to 600, and 600 is equal to mu by mu naught. So mu is equal to 600 mu naught. And so mu naught, you already know that it is 4 pi into 10 to the power minus 7. So you must simply multiply this. So your answer is 2.4 pi into 10 to the power minus 4 Tesla meter per ampere. So your answer is going to be as B. Okay. So it is as, your answer is going to be as D, because the power is 10 to the power minus 4. So your answer is D. This is as simple as this. Okay. Now the next question is, a spherical conductor of radius 10 centimeter has a charge of 3.2 into 10 to the power minus 7 coulombs distributed uniformly. What is the magnitude of electric field at a point 15 centimeters from the center of the sphere? Okay, so we have to calculate at a point 15 centimeters. So obviously this point is going to lie outside the sphere. If it was lying inside the sphere, then we must have applied the formula kq upon capital R cube into small r. But over here it is lying outside the sphere, so the formula is as simple as this. It is kq upon r square, and because the formula is kq upon r square, just put the value of k and the value of q and the value of r square. So k is 9 into 10 to the power 9, q is given to you as 3.2 into 10 to the power minus 7 upon r square. So this is 15 centimeter square. So 15 into 10 to the power minus 2 meter square. You just solve it and you are going to get your answer as A. Okay. Now let us come to the next question, that is question number 108. In question number 108 over here, a series LCR circuit is connected to an AC voltage source. Okay, a series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, the phase difference between the current and voltage is pi by 3. If instead C is removed, the phase difference is again pi by 3. The power factor of the circuit is. So over here phi RC is given to you as what? Phi RC is pi by 3. Okay, that is tan pi by 3 is equal to XC by R. From over here XC is equal to root 3R. Similarly for phi RL also you are going to write as pi by 3. So tan pi by 3 is equal to XL by R. So XL is equal to root 3R. So tan phi is going to become XL minus XC by R, and because XL and XC are same, so XL minus XC by R is equal to 0. and because it is equal to 0, therefore cos phi is equal to 1. So the answer is B over here. Okay. Now let us come to the next question. So the next question over here is, a capillary tube of radius r is immersed in water and water rises in it to a height h. Okay, the mass of the water in the capillary is 5 gram. Another capillary tube of radius 2r is immersed in water. The mass of water that will rise in the tube is, okay. So first of all, you know that mass of liquid is what? It is pi r square h into rho, because pi r square h is what? Pi r square h is basically the volume, and into you are going to do rho. So volume into density, it is equal to mass. So mass is pi r square into rho, and basically what you are now going to do for h, you are going to write 2t cos theta upon rho r g. So over here you can see that mass becomes directly proportional to r, because there is one r square in the numerator, there is one r in the denominator, they both get cancelled. So m is basically proportional to r now, and because m is proportional to r, so because r has become now 2r, so mass will become 2 times and it will become 10 grams. Okay, so mass is going to become 10 grams. So your answer is B. Okay. Now in question number 110, the next question we have, in a Young's double slit experiment, if the separation between the coherent sources is half and the distance of the screen from the coherent sources is doubled, then how many times does the fringe width become? Now this is also a very easy question. You know that beta is equal to lambda into capital D by small d. Capital D has become twice and small d has become 1 by 2. So this 1 by 2 will go up and it will become 4 times. Okay, so the answer is 4 times, because beta is equal to lambda d by small d, so it is equal to 4 times. So the answer is B. Okay. Now the next question is, that is question number 111 according to the paper. Okay, and before proceeding into the question number 111, let me tell you that please download the NEETKAKAG app. Okay, the NEETKAKAG app is a very useful app. It is a very premier app in order to make you prepare for the NEET examination and JEE examination. And on this particular app, you will be getting detailed video lectures of all the subjects. You will be getting detailed video lectures. Also, you will be getting detailed study contents, detailed written contents, detailed notes. Okay, so NEETKAKAG app is one of the best apps in the country to make you prepare for your NEET examination, to make you prepare for your JEE examination. It has teachers from all over the country who are best in their field, and it has the entire NEETKAKAG app in association with Cellsius Institute is one of the best things that you can get in the entire nation if your aim is AIMS and if your aim is IIT JEE. Also, one more thing that I would like to emphasize is that in association with NEETKAKAG and Sciences Institute, a book named NCERT Nature has been launched already for biology and is in the process of being launched for chemistry and physics. And in the NEET examination that occurred here today, very few, in fact, no question was out of the book, that is NCERT Nature Biology. Because NCERT Nature Biology has already been launched, so I'm telling you. And as far as NCERT Nature Chemistry and Physics is concerned, also no question in this examination were out of the NCERT Nature Chemistry and Physics. However, they are not launched yet. They are on the verge of being launched, but everything is done. Proofreading is also done. They have already gone into the print, but NCERT Nature Biology is already there in the market. You can buy the book, you can see, you can tally that all the question, each and every question was from NCERT Nature Biology. Okay, so now let us come into the next question, that is question number 111. So it is telling that for the logic circuit shown in the truth table, okay, and this is logic circuit, you basically have to do 0 0 1 1, so you already know that it is like playing game. So I'm not going to discuss this one because this one everybody of you must be knowing. So the answer is D basically for this one. Okay, so the next question is, the color of a resistance is given below. So the color of the resistance, basically the diagram is not being shown to you on the screen, but you must be seeing the diagram in your question paper. So the question, because the diagram in the question paper you must be clear to you. So according to that diagram, basically I will be telling you that what you had to utilize. You had to utilize BB Roy, Great Britain, Very Good Wife, where B is black, then brown, then R is red, orange, yellow, okay, then green, then again blue, and then violet, okay, then again gray, and then white. Okay, so and the first letter represents 0, the next represent 1, then 2, then 3, and up till 9. So first 3 of them, so first 2 of them basically gives you the digits, okay? So first 2 of them would be giving you digits, the next one will be giving you the power of 10, and the last one will be either gold or silver or none. So if it is gold, the tolerance will be 5%, okay? So you can utilize that concept, BB Roy, Great Britain, very good wife, and you are going to get the answer as 470 ohms, and the tolerance will be 5% because it was gold, okay? Now, the next question is, the capacitance of a parallel plate capacitor with air as medium is 6 microfarad. With the introduction of a dielectric medium, the capacitance becomes 30 microfarads. What is the permittivity of the medium? So this is a very easy question. That is, C is what? C is K epsilon naught A by D, and C naught is simply epsilon naught A by D. So if you do C by C naught, then you are left with what? K. And C by C naught according to this question comes out to be 30 by 6, so that is 5. Now because K is 5, now epsilon is what? So epsilon is what? It is epsilon naught into ER, and that ER is also known as K. So epsilon is what? It is epsilon naught into K, and epsilon naught is 8.85 into 10 to the power minus 12, and into K is 5. So your answer for epsilon, that is the permittivity of the medium, comes out as 0.44 into 10 to the power minus 10 coulomb square Newton to the power minus 1 meter square. Okay, so this is as simple as this. Okay, now the next question, which is one of the easiest question, and even a class 9th boy would be, even a class 9th student would be able to solve it, is a ball is thrown vertically downwards with a velocity of 20 meters per second from the top of a tower. It hits the ground after some time with a velocity of 80 meters per second. The height of the tower is, okay, so the height of that, you can simply utilize V square equal to U square plus 2GH, and you can get the height of the tower as 300 meters. Okay, so this is as simple as this. You utilize V square because V is also given, U is also given, V square equal to U square plus 2GH, and thereby you are going to get the height of the tower. Okay, now the next question is question number 115. A body weighs 72 newtons on the surface of Earth. What is the gravitational force on it at the height equal to half of the radius of the Earth? Okay, so because the height is half of the radius of the Earth, we cannot directly utilize the formula G dash is equal to G into 1 minus 2H by R, but we can go with our base rule, that is G dash is equal to G upon 1 plus H by R whole square, and we can simply put the values. So we are going to get GH as equal to 4 by 9G, and from there we are going to get it as 32 newtons. Okay, so this is as simple as this. Okay, now let us come to the next question, that is question number 116. So it is two particles of mass 5 kg and 10 kg respectively are attached to two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from the 5 kg particle is nearly at a distance of. So this is one of the easiest questions of center of mass. Just you will have to utilize the formula. So X center of mass is 5 into 0 plus 10 into 1 by 15. So it comes out as 2 by 3 times. So it is 67 centimeters. So the answer is B, obviously. Okay. Now the next question, it is a theoretical question. It states that the increase in the width of the depletion region in a PN junction diode is due to. Okay, so the width will increase only due to the reverse bias. The forward bias will lead to the decrease in the width. Increase in width of the depletion region means potential barrier is increasing, and it is obviously due to the reverse bias only. So answer is reverse bias. This is a basic theory of NCERT, okay, and basic theory of the PN junctions. Okay, now let us come to the question number 118 according to the code that we have. So question number 118 is light of frequency 1.5 times the threshold frequency is incident on a photosensitive material. What will be the photoelectric current if the frequency is halved and intensity is doubled? Okay, once you halve the frequency falls below the threshold frequency because it becomes 0.75 times of the threshold frequency. And once the frequency is below the threshold frequency, no electrons will be liberated. And because no electrons are liberated, so what happens basically, the photocurrent becomes 0. Okay, so the answer is 0. So hopefully it's clear up till now. Now let us proceed into the next question. So the next question is, assume that light of wavelength 600 nanometer is coming from a star. The limit of resolution of a telescope whose objective has diameter 2 meter is. Simple application of formula, limit of resolution is 1.22 lambda by A. So 1.22 into 600 into 10 to the power minus 9 divided by 2. So your answer is 3.66 into 10 to the power minus 7. So your answer is D. So you can see that in the NEET examination, all of you who fear the physics are somebody who are doing ridiculous things to you. The reason is that physics is basically the easiest one of the three that is going to appear over there. You just have to put the value and get the result. At the end of the day, before appearing into the NEET examination, you must keep one thing in mind, that you must be thorough with all the formula. Even if you remember all the formulae, then you are going to solve most, that is, we are going to get over 150 marks in physics in the NEET examination, even if you are able to solve, or even if you are able to remember the formula. It's just putting the value and getting the result. It's not a hardcore type of physics. It's not rocket science as far as NEET is concerned. Okay, now let us come to the next question. So the next question is: a resistance wire connected in the left gap of a meter bridge balancing a 10 ohm resistance in the right gap at a point which divides the bridge in the ratio 3:2. Now if the length of the resistance wire is 1.5 meter, then the length of 1 ohm resistance wire is. So basically, you must remember that in Wheatstone bridge, what we do that P by Q equal to R by S if it is balanced. So what we are going to do, we are going to do over here X by 3 is equal to 10 by 2. So from over here we get X is equal to 15 ohms. Okay. Now, according to the question is telling that 15 into X must be equal to 1 into 1.5. So from over here we get X is equal to 1 into 10 to the power minus 1 meter. Okay. So the value of the resistance, or the value of the length for which the resistance will be 1 ohm is 1 into 10 to the power minus 1 meter. Okay. So this is as simple as this. Now the next question is: light with an average flux of 20 watt per centimeter square falls on a non-reflecting surface at normal incidence having surface area of 20 centimeter square. The energy received by the surface during a span of 1 minute is. Okay, so first of all, it has given you the intensity, that is the flux, and you multiply it with area. So when you multiply it with area, you get the power, and then you multiply with time and you get the energy. So you just have to multiply the flux with the area, and then you'll have to multiply this entire thing with the given span of time, so that you can calculate the total energy. So it is 20 into 20 into 60, so it is 24 into 10 to the power 3 joules. This question is as simple as this. One-liners, absolutely one-liners. Okay. Now we are into the next question, that is question number 122. It is telling that a ray is incident at an angle of incidence I on one surface of a small angle prism with angle of prism A, and it emerges normally from the opposite surface. Remember, because it is emerging normally from the opposite surface, so R2 is equal to 0, because the angle with the normal is 0, R2 equal to 0. Remember this thing. Now if the refractive index of the material of the prism is mu, then the angle of incidence is nearly equal to. Why it's telling nearly? Because we are going to use one approximation over here. Okay. So you know that according to the theory of the prism, the R1 plus R2 is equal to the angle of the prism. But as I told you, because it is emerging normally, therefore R2 is equal to 0. And as R2 is equal to 0, therefore R1 equal to A. Now let us apply Snell's law. Okay, at the first angle, the first surface. So when we are applying Snell's law at the first surface, then what is going to happen over here? So what we are going to do now, we are going to do R1 plus R2 equal to A, and what you are going to do, 1 sine I is equal to mu sine R, R1, and instead of R1 you are going to write as A. That is what you are applying Snell's law. So mu1 sine I1 equal to mu2, or mu1 sine I equal to mu2 sine R. But because mu1 is air, so what we are going to do, we are going to write mu1 as 1. So 1 sine I is equal to mu sine R, and instead of R we are going to write A. So 1 sine I is equal to mu sine A, but as angles are small, so sine I is equal to I and sine A equal to A. So 1 into I equal to mu into A, or simply I equal to mu into A. So this is our answer. So the answer is B. Okay. So hopefully this question is clear to you. Now let us proceed into the next question. That is question number 123 according to the code that we are having. So this question is: a 40 microfarad capacitor is connected to a 200 volt 50 hertz supply. The RMS value of current in the AC circuit or in the circuit is nearly. So you already know that IRMS is equal to VRMS divided by XC, and XC is 1 by omega C. So that will go at the at the numerator. So IRMS is V0 by root 2 into omega C, and just put the values. V0 is given to you, omega is given to you. Because omega can be easily calculated because it's 50 hertz supply, so you know that omega upon 2 pi is equal to f, so we can calculate omega, and C is also given to you. Put the values and your answer is 1.7 amperes. Okay. Now, dimensions of stress, this is again very easy question. Stress is equal, dimension of stress is same as dimension of pressure, so you already know the answer over here, force upon area. Okay, so force is what? M1 L1 T minus 2 divided by L square, so this becomes M1 L minus 1 T minus 2, so the answer is C over here. Okay, now it's telling you the Brewster's angle IB for an interface should be. Now it's not mentioning for which interface, whether it's glass air or whether it is water air, but we have the ranges from 45 degrees to 90 degrees for different materials, and which is obviously you can check the data from NCERT also. So your answer is going to be B over here. This Brewster's angle is going to lie in between 45 degrees and 90 degrees. Okay, because the second surface would obviously have a refractive index greater than air. Okay, and it will not have obviously refractive index more than infinite, obviously. So because it is lying in between 1 and infinite, so in between tan 45 and tan 90, so it is in between 45 degrees and 90 degrees. So this is what our answer must be. Okay. Now the next question is, that is question number 126 according to our code. So it is the wire of length L, area of cross section A is hanging from a fixed support. The length of the wire changes to L1 when mass M is suspended from its free end. The expression for Young's modulus is, now the question from elasticity chapter cannot be easier than this. Okay, Young's modulus is the ratio of stress to strain. Stress is F by A and divided by strain is delta L by L. So that L goes into the numerator. So it is F by A into L by delta L, and delta L over here is L1 minus L. So your answer is going to be mg into L upon A into L1 minus L. So your answer is obviously C. Okay, this is as simple as this. A question cannot be easier from this chapter than this particular question. Okay, now the next question is question number 127, which states that a short electric dipole has a dipole moment of 16 into 10 to the power minus 9 coulomb meter. The electric potential due to the dipole at a point at a distance of 0.6 meter from the center of the dipole situated on a line making an angle 60 degrees with the dipole axis is, you already know the formula, that it is Kp cos theta upon r square. Just put the values and you are going to get it as 200 volts. Okay. Now the next question is, in a guitar, the two strings A and B made up of same material are slightly out of tune and produce beats of frequency 6 hertz. Now when tension in B is slightly decreased, okay, the beat frequency increases to 7 hertz. Okay, if the frequency of B will be, so the frequency of B will have to calculate. So you know that FB is directly proportional to T, and FA minus FB, according to the question, it was given to you as 6. Okay, so FB is equal to FA minus 6, so it is going to be 524 hertz. So your answer is going to come as A. Okay, now in question number 129, we have an electron is accelerated from the rest through a potential difference of V volts. If the de Broglie wavelength of the electron is 1.227 into 10 to the power minus 2 Newton meter, then the potential difference is, okay, so you know that when you are accelerating through a region of potential, so that change in potential energy E into V, that is Q into V, but Q is generally over here, in this case it is E. So E into V is, that is change in potential energy. Whatever will be the loss in the potential energy will appear as the gain in kinetic energy. It will manifest itself as the gain in kinetic energy. So this E into V equal to delta Ke, and delta Ke can be written as P square by 2m. So we have E into V is equal to P square by 2m over here. Now we already know that from the de Broglie wavelengths equation, lambda equal to H by P. Okay, so instead of P square, you can write over here, instead of P square by 2m, what you can write, V is equal to H square upon 2me lambda square, and now just put the values over there and you are going to get the answer as 10 to the power 4 volts. One more suggestion that I will be giving you, that during the course of solving the question, do not cut or do not solve the quantities at the intermediate step. Write them as they are, and in the final step everything is going to cancel out. Your answer is going to come as 10 to the power 4 volts. Never make the mistake of solving at each and every step, because that is time consuming and you can make mistakes also. So put the values as they are, and in the final step you can see that most of the things are automatically cutting out. Okay, so the answer for this question is 10 to the power 4 volts. Now question number 130, it states that the solids which have negative temperature coefficient of resistance. So negative temperature coefficient of resistance is defined for semiconductors only, because what happens when you increase the temperature, the conductivity of semiconductors increase. Somebody of you may also answer it as insulators and semiconductors both, but the thing is that in case of insulators, with rise in temperature there is no consistent, as far as ideal insulator is concerned, with rise in temperature you cannot see a decrease in the resistance. That is why they are known as ideal insulators. So as far as our institute is concerned, as far as we are concerned, we will be giving our answer as semiconductors only, because insulators would rather get destroyed than changing their resistance. Insulators resistance is generally considered as infinite only, so we'll be considering this only for semiconductors. Okay, so the answer is semiconductors only. Now the question number 131, it states that the energy required to break one bond in DNA is 10 to the power minus 20 joule. The value in electron volt is, now I do not know if I have to solve this question for you. It's just a conversion of electron volts into joules. Okay, so it's as simple as this. You already know 1 electron volt is 1.6 into 10 to the power minus 19 joules. Therefore your answer is 0.06. that the answer is B. Okay, now next question states that the quantities of heat required to raise the temperature of two solid copper spheres of radii R1 and R2. R1 is 1.5 R2 through 1 Kelvin are in the ratio. Now you already know that delta Q1 by delta Q2, because it is ms delta T upon m1 s1 delta T1 upon m2 s2 delta T2 by delta T same. Okay, and because they are of the same material, so S is also same. So mass, now mass is density into volume, because materials are same, so densities are also same according to the question. So delta Q1 upon delta Q2 will just be equal to V1 upon V2, and if it is V1 upon V2, then it is going to be R1 cube upon R2 cube, and therefore your answer is delta Q1 upon delta Q2 is going to be 27 by 8. So your answer is D for this particular question. Okay, now the next question is, which of the following graphs represent the variation of resistivity with temperature? Which of the following graphs represent the variation of resistivity with temperature? Okay, now if you apply the equation rho is equal to rho naught 1 plus alpha T, then your answer is going to be equal to D. But it's not only rho naught 1 plus alpha T, but there is some other things also, that is T squared, T cube type of equations, which are generally ignored because alpha is small. But if you consider them and if you refer to NCERT, so it is specifically mentioned for copper that your answer is going to be B. Okay, so you'll have to refer NCERT and your answer is going to be B. Okay, now next is question number 134. So it is telling that for the transistor action, what or which of the following statement is correct? Now this is very plain line. This line is absolutely given in NCERT. This is a very plain line that for the transistor action to take place, the base emitter and collector regions, the base emitter or the base region must be very thin and lightly doped. Okay, so that the base region allows the electrons to come and does not neutralize most of the electrons. It neutralizes only 5%, and rest of the electrons, they generally pass into the collector region where they get neutralized. So you have already studied the theory in NCERT that only 5% of them get neutralized. So IB is 5% of the total current that is passing over there. So for the transistor action to take place, IB is 5%. That is, the base must be first of all very thin, because it only acts as a boundary region in between the collector and emitter, and it must be lightly doped also. This is absolutely written in NCERT, and this is how the transistor works. So your answer is C, that is, the base region must be very thin and lightly doped. Okay, and the last and final question is of this paper, for which one of the following Bohrs model is not valid? Again a very silly question. It is telling singly ionized helium atom, obviously it's going to take the form of hydrogen. For this it will be valid. It is again telling deuteron atom. Again for this it will be valid. Deuteron is an isotope, or deuteron is basically belonging to hydrogen family only. Now C is singly ionized neon atom. Okay, now this is going to be our answer, because neon, it comes into the noble gas category, and singly ionized neon atom, if you are going for, then Bohrs model will not be exactly applicable for this. Now final answer is hydrogen atom. For hydrogen it is obviously applicable. So for single electron species, if you are considering, it is applicable. Now if you are going for singly ionized neon atom, for this one it's not going to be applicable. So for this our answer is C. So you can see that overall the paper was very easy. Most of the questions were very easy, and again I am emphasizing that for the NEET examination, what you will have to do, you will have to basically concentrate on the formulae only and a bit of theory. Okay, so once again I am requesting you to download the complete answer key is then available to you. Complete answer key is available to you over here. You can take the screenshot of the answer key, and again I am telling you that please subscribe to the NEETKAKAG app. Please subscribe to the NEETKAKAG platform, that is, you download the app of the NEETKAKAG, okay, so that most of the stuffs that are related to JEE, Main, Advanced and NEET are available to you in the shortest interval of time and in the shortest manner, in the most efficient manner, okay. And all the elaborate lectures, all the elaborate theory and all the elaborate notes, more than a lakh of questions in all the subjects, combining all the subjects, are applicable or are available on that particular app, the NEETKAKAG app. So please download the app for more beautiful content regarding NEET and JEE. Thank you.